is on its own on one side of the equal sign. So we'll take this and we will plug it in for y in the other equation. So we're going to take this and say that this is the same as negative 5, 6x plus 1 plus 2 equals 1/3 x. And then we can solve for x here. So let's see. So I've got negative 5, 6x plus 3 equals 1/3 x. I've got to move the x's. So I'm going to add 5/6 x to both sides. And so I get 3 equals 1/3 plus 5/6. That's like 2/6 plus 5/6. So that gives me 7/6 x. So 3 equals 7/6 x. And if I divide both sides by 7/6, I will get, I'm going to move this up here, x equals 18/7. And you could put that in decimal form if you want to, but I'm just trying to practice with fractions here. So x equals 18/7. Then we got to find our y. So we can use this equation, y equals negative 5, 6x plus 1, and plug in our x value. So y equals negative 5/6 times 18/7 plus 1. And we can multiply fractions here. So we've got y equals negative 5 times 18 is negative 90. 6 times 7 is 42 plus 1. We simplify that fraction, so that's going to be y equals negative 45 over 21 plus 1. And I want to add these fractions. I'm practicing with fractions here. So 1 is the same as 21 over 21. And if I add those two together, I get y equals negative 24 over 21. And so total, I have, if we simplify that, y equals negative 8 over 7, since we can divide those both by 3. And my coordinate parent answer is 18/7, comma, negative 8/7. So we can do this with fractions as well. And then finally here, we've got x minus 16 equals negative y, and 2x plus 2y equals 12. In this case, we actually don't have a loneliest variable yet. We need to solve one of our equations to make a lonely variable. And if I look at this equation on top, I think to myself, it'd be really easy to change this negative y to a positive y. It's not a lonely variable yet because it's negative, and we want the positive version. So if I take this whole equation and multiply it by negative 1, that's a technique that we don't use very often in substitution, but we can totally use it. Any way that we can manipulate an equation to get what we want will work, because we could also add 16 to both sides. That'd be fine too. So I'm going to multiply by negative 1, and that's going to give me negative x plus 16 equals y. And now I have a lonely variable all on its own. I'm going to substitute negative x plus 16 for y in the other equation. So I've got 2x plus 2. Make sure you put this in parentheses. Negative x plus 16 equals 12. And now that I've got parentheses here, I have to remember to distribute. So 2x plus negative 2x plus 32 equals 12. And if I simplify this, these two cancel each other out, and I end up with 32 equals 12. And remember what we talked about on the front? This doesn't make sense because 32 does not equal 12. So this is going to be a no solution system. If I were to graph this system, I would see that the system has no spot where the two lines intersect. They would be two parallel lines. All right, we've got one more strategy. This one tends to be my favorite strategy, but everybody's got their own opinion. So this is the solving systems by elimination strategy, and I'm going to call this the equal and opposite strategy. And the reason for that is because I want to find or align these two equations so that one variable is the equal and opposite of another one, because my goal is to eliminate a variable. So I can only use elimination when my equations are set up like this already, with the x's on top of the x's, the y's on top of the y's, the equal signs on top of each other, and then the constant terms on top of one another. If my equations are not set up in this way, I'm going to need to change them around in order to get them in this specific form. Then I look at my variables and I say, all right, if I wanted to eliminate the x's, I would need this x and this x to be equal and opposite of each other. If I wanted to eliminate the y's, I would need the two y's to be equal and opposite of each other. And I ask myself, what's the easiest way to make that happen in any given system of equations? So here I see that 2x and 2x, they're already equal, they're just not opposite. But I can change them to be opposite because I can take either of my equations and multiply the whole thing by -1, and that will turn my positive 2x into a negative 2x. Of course, it'll also change everything else in the equation. Now I have negative 4y equals -9. So I have to remember to multiply everything else in the equation as well. But now I have equal and opposite variables, which means if I add the two equations together, don't look at the top one, just the two bottom ones, I can eliminate 2x plus -2x. It goes away. They're gone. And now what I have is -3y plus -4y, so that's -7y, equals 4 plus -9, which is -5. So then I can simplify this to figure out what my y coordinate is. So I'm going to divide both sides by -7, and I get y equals 5/7. It's another fraction one. We can deal with fractions. So y equals 5/7. I need to find what x is equal to. So I'm going to do the same thing that I've been doing before. I'm going to take one of my original equations and plug in y. So I'll take my first equation here. I'm going to not think about the fact that I multiplied by -1. I'm just looking at the original. And I have 2x plus 4y equals 9. So I can say 2x plus 4, I know my y. My y is 5/7. So 2x plus 4 times 5/7 equals 9. And I can solve this equation to figure out the value of x. So I've got 2x plus 4 times 5 is 27 equals 9. We'll subtract 27 from both sides. And I'm thinking about this in terms of multiplying, or not multiplying, but adding fractions. And I'm thinking, well, 9 in terms of sevenths is going to be 9 times 7, or 63/7. So I'm thinking about doing 63/7 minus 27. So I've got 2x equals 63 minus 20 is 43/7, just so I can keep this in terms of fractions. I'll divide both sides by 2, and I got x equals 43/7 divided by 2, if you remember, is the same thing as 43/7 times 1/2, and that's going to be 43/14. So remember that dividing a fraction by a number is the same thing as multiplying by the reciprocal of that number. So x is equal to 43/14. And if I put those two together, I've got my coordinate 43/14 for the x coordinate and 5/7 for the y coordinate. Pen is running out of ink here. The next example of solving by elimination shows what I was talking about earlier, which is that this equation is actually not set up to eliminate yet, because I have the x's on top of the x's and I have the y's set up on the y's and the constant terms on top of one another. But this equation doesn't have the equal signs in the same place yet, and I can't change this until the equal signs are in the right position. The bottom equation is fine, but the top equation needs to be in standard form. I need to put the y on the other side. So I'm going to subtract 3y from both sides to get myself started here. And that'll give me x minus 3y equals 10. So I've changed that first equation, and now when I look at these equations, I see that they're equal. My x's are equal anyway, but they're not opposite yet. We'll do the same thing, maybe that we did it before, or we could do a different thing. So we could multiply by -1. Let's do something different. Let's eliminate our y's this time. So my bottom equation has a -3y, and to cancel out a -3y, I would need a positive 3y. So I think to myself, how do I make this y a positive 3y? Pretty simple. I take that whole equation and I multiply it by 3 to make that positive 3y. So that gives me 3x plus 3y equals 3 times 6, which is 18. And again, I'm only looking at the two newest equations that I have, and I see I have equal and opposite variables, so I can go ahead and eliminate them. And I have x plus 3x, so 4x, my y's are gone, equals 28, because 10 plus 18 is 28. Solve for x from here, divide both sides by 4. We get x equals 7, there's half of our answer. And to find the other half of our answer, we can put it into any of these equations that we want to. I see a really simple equation hiding in here, x plus y equals 6. So I'm going to use that. So I'm going to say 7 plus y equals 6. And then subtract 7 from both sides. Y equals -1. So my coordinate pair answer is 7, -1. And finally, here is a system of equations. It's all set up to eliminate, or rather it's in the form that we need, x's, then y's, then constant terms. They're both in standard form. 2x plus 3y equals 8, and 3x plus 5y equals 2. And I have to try and figure out how to make these equal and opposite. So I'm going to look at these variables, and I'm looking at the x's just because they come first here. And I say, well, 2 and 3 are obviously not equal and opposite. But if I multiplied my 2 by 3, I would get 6. And if I multiplied by 3 by 2, I would get 6. Then I would have equal variables. And if I multiplied one of those by a negative, I would have a -6 and I would have a positive 6x. And then I could cancel them out. So I'm looking for what to multiply by, and I'm allowed to multiply both equations to make them equal and opposite. So I'm going to multiply both equations. My first one, I'm going to multiply that by -3. I'm going to decide that this is going to be my -6 term. And then I need a positive 6 term to balance it out, so I'm going to multiply the whole bottom equation by 2. So here, -3 times 2x is -6x. Remember to multiply by everything else as well. Got -9y equals 8 times -3, or -24. On the bottom, 2 times 3x is 6x. 2 times 5y is plus 10y. And 2 times 2 equals 4. Now I can just go ahead and simplify. I can eliminate a variable here. I can eliminate my x's. So I have I have positive y equals -20. So there's half my answer already. And I can just pop this back in any of these. I'll pop it back in the top one just because it looks simple enough. So 2x plus 3y equals 8. So 2x plus 3 times -20 equals 8. That's 2x minus 60 equals 8. Add 60 to both sides. And I got 2x equals 68. And then finally, I want to divide both sides by 2. Get x equals 34. So if I want to make that coordinate pair, I've got 34, -20. And that's all there is to solving systems. We're going to solve a whole bunch of systems coming up this year, so I want to make sure that you are ready for that. Make sure you take some time to review any of these solutions or any of these strategies. You can choose any way to solve. If the worksheet doesn't specify use substitution or use elimination, you can choose what you want to use. That's all for today. Hope you have a great day, and I will see you next time.